Hello, everybody. So welcome to our week 2, lecture 2 lecture, which is going to be dealing with limits on graphs. I don't know if that's really the best title, but we're going to be dealing with limits and we're going to be looking at limits on graphs. So that's what I decided to call this. So this is going to be the first of maybe 5 or 6 lectures on the topic of limits that we're going to cover in this course. And there are some specific learning objectives that we're going to go over. So what this lecture is supposed to do is to help you meet the following course learning objectives. The first is going to be the main SLO. There's, I think, 4 or 5 SLOs for this course. SLO A is apply the concept of limits. This entire chapter 2 in your book is going to be covering limits. And under that broad SLOA, apply the concept of limits, there's some specific things we're going to learn. So we're going to be doing A2 today, which is going to be evaluating limits using appropriate techniques and properties of limits. So appropriate techniques is going to be, in this case, we're going to be evaluating limits using a graph. And how do you do that? Well, we're going to learn the appropriate techniques and some properties of limits. Also, we're going to be doing that by making appropriate use of available technology. Well, of course we are, right? We're going to be doing this on a computer. That's what we're using to graph our functions. And yeah, so that's going to be our available technology for today. Okay, so let's, oops, skipped a few pages here. Okay, there we go. So why does my page keep turning? That is really, okay. Please stay. So we're going to be, the study of calculus is based on the concept of limits. As I've said, this lecture is the beginning of your studies, and we're going to be evaluating limits using several techniques in the course. And in this first lecture, we're going to learn what the limit of a function looks like on a graph. So we've mostly talked about that already. So let's go ahead and move on to the next slide. And this is going to be our notation for a limit that you're going to have to just become familiar with here. So the way you would read or write a limit. So the limit of a function f of x as x approaches a is written this way. So you have the limit symbol, LIM. Under that, you write x, a little arrow, a. That indicates that x is approaching a. So that's what, that's how you say x approaches a. And then what is the function that has the limit? Well, it's called f. Well, in this case, it's called f. You could have the limit as x approaches a of anything here. So this f of x could be any kind of function. And we're just using f of x as sort of our placeholder function. Okay, now we're going to be evaluating this, which means that the limit as x approaches a of f of x, whatever that means, is going to be a number. If it exists, it's going to be a number. So what we'll do is you just say that the limit of f as x approaches a, or the limit as x approaches a of f, you can read it multiple ways, is equal to L, and presumably L is going to be a number. Okay, so again, it just says it up here. If you want to say that the limit of f of x as x approaches a is equal to the number L, you write it like this. So you can write a limit and then equals and then a number, right? Just like you would say something like, you know, x equals 5, y equals 3. Well, this whole thing here, limit of f of x as x approaches a, that can be equal to a number. Okay, so that's how you read it, and that's how you write it in symbols. It kind of looks like there's a little bit of extra space here between the f and the x. That's just the font that they use in the typesetting for this. So yeah. Now, what is a limit? Why are you changing pages? I'm going crazy here. So what is the idea of a limit as related to a graph? Because we're going to look at graphs of functions in this lecture. So I'm listing out the steps here, and I'll read them to you. But then, we're going to have to spend some time looking at real graphs and seeing how to do this, because I don't know how much sense it will make when we just read these steps. Okay, so the idea of a limit as it's related to a graph. So what we're going to do is we're going to pick a point on the graph. So like if you're looking at a picture of the graph, you just put your finger on the curve. Okay, so pick a point on the graph of a function f of x to the left of x equals a, right? So x equals a is somewhere on the x-axis, right? So it could be like x equals 3, for example. And you would just need to put your finger on the curve to the left of x equals 3. That's what we're saying here. Okay. Now, what you do is you're starting out to the left of x equals a, because I said so. But then you're going to trace the graph. So you're going to trace the curve towards x equals a with your finger, or whatever you're using to trace, mouse pointer. Okay, so you trace the graph towards x equals a. So we're starting out So we're starting out to the left of x equals a, and then if you move towards x equals a, you'll actually be moving towards the right. So you're starting on the left and you're moving towards the right. Okay. Now, when you trace the curve, so when or if you get to x equals a, you'll be at some y value, right? So you're paying attention to the x-axis up in the first two steps, but after you trace the curve over to x equals a, then you're going to look at the y value. And so you look at the y value at that point and you see what it is. So call it L. Okay. So we're just tracing the curve. And then what you do after you trace the curve is you're going to trace the curve again, a second time. But what you're going to do the second time is, instead of starting to the left of x equals a, like we said up here, you're going to start to the right of x equals a and trace it left towards x equals a, right? So you trace the curve twice, once from the left and once from the right. And when you do that, you're going to get to some y value. And if you get to the same y value, so it has to be the same y value. If you get to the same y value, which we decided to call L, both times, then we say the limit of f of x as x approaches a is equal to L. And if something goes wrong with this process, there's no L for some reason, and we'll talk about why that might be, then the limit does not exist. So this is your key for doing this on a graph. Trace the curve twice, once from the left, once from the right. And if you get to the same point on the graph, then you have a limit. Okay, so that's the key to this. So here's going to be our first y. Y. I think it's the scroll wheel on my mouse. It's the only thing I can think of. All right. So here's an example. So this is going to be a graph with a limit. Okay. Wait, no, this is going to be a graph with a limit. So example 1 of a graph with a limit. Okay. So notice this graph is continuous. Okay. Now continuous just means there's no holes in the graph. There's no breaks or anything, right? So this curve just comes up here, passes through this point that I've helpfully labeled 3,2, and then it continues on and leaves up here. And it's just one curve with no holes or breaks or jumps or anything weird going on. Just a really normal looking curve. Okay. Now what we're going to do here is we are going to evaluate the limit as x approaches 3. Okay. Why 3? Because that's the one that I labeled here. Okay. So when I say we're going to try to follow these steps that I gave you on the previous page, let's look at that. So you pick a point on the graph to the left of x equals a. We're using x equals 3. And we trace the graph towards x equals a. Again, we're going to use x equals 3. So what does that look like? Well, here's your curve. So x equals 3 is right here, in like above and below that 3,2. And we're going to start out to the left of this point. So anywhere on the curve. So you put your finger, or in my case, the mouse pointer, somewhere on the curve, like right here. Okay, so I'm just putting my finger right here. Then I trace this curve. So I trace this curve towards x equals 3. And I end up here, don't I? So you start out here, you trace the curve, you end up here, right? Now, what happens when we get there? Well, according to the steps, when or if you get to x equals a, so x equals 3, you will be at a particular y value. Call it L. So start out here, you trace the curve this way. This is x equals 3. And then you need to figure out what the y value is. So the y value right here is 2, right? So you end up at the point 3 comma 2. So the y value is 2. So this is what we're going to call L. So this is going to be L, 2. The 2 is. Okay. Now do that same thing, but this time you're starting out on the right side. So instead of starting over here on the left, you have to start over here on the right. So again, you pick a point on the curve. Anywhere is fine. Like right there where the mouse pointer is. Trace it towards x equals 3. Follow the curve, follow the curve, follow the curve. You end up right here. What's the y value right here? The y value is 2. So from the left, you end up here at 2. From the right, you end up down here at 2. Both times you end up in the same spot. And what that means is the limit of f of x as x approaches 3 is 2. So the 3 is the a, and it's an x value. And the 2 is the limit, and it's a y value, right? So this is an x value. This is a y value. Right? Y equals 2 right here. Okay. And then that's how you evaluate a limit using a graph. So it's a very simple process, but you have to know what can trip you up basically. So let's look at another example. So if you look at this example, you can look at the picture and you can see that it's actually the same curve, very similar looking curve. Except for one difference. So the difference this time is that there's actually, you have your nice smooth curve, but this time at 3 comma 2, there's a hole, right? The point 3 comma 2 is actually missing. It's not there on the curve. And instead of putting it on the curve, I put it as an isolated point down here at 3 comma 1. So 3 comma 2 is empty. 3 comma 1 is where the point actually is, okay? Now, if you're going to evaluate the limit again, as x approaches 3, we follow our same steps that we followed last time. Okay, so how do we do it? Well, you start out on the curve to the left of 3. So just like before, somewhere over here on the left-hand side, maybe right here, that's where you start tracing the curve. So you trace the curve towards x equals 3. And you stay on the curve. So you're staying on the curve. Trace, 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 trace. You end up here, don't you? What's the y value right here? The y value is 2. Right? You trace the curve, you end up here where that empty circle is. And the y value is 2. Now what about this point down here? Nothing. Who cares about that? We don't care. Nobody said to look at that point. We said trace the curve. Trace the curve from the left, you end up here. Do the same thing from the right. So you're starting out up here maybe. Trace the curve towards x equals 3. Trace, 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 trace. You end up here again. From the left, you end up at a y value of 2. From the right, you end up at a y value of 2. Both times you're at a y value of 2, and that means the limit is 2, right? So the limit of f of x as x approaches 3 is 2, just like before, right? On this example right here, 3 comma 2 was a point on the graph. On this example here, 3 comma 2 is not a point on the graph, but we don't care. The limit is what happens when you trace the curve. You trace the curve and you end up here at this point. You don't end up down here, right? You can't get to here by tracing the curve. So this point has nothing to do with the limit. Okay, this could just be not here at all. It could just be curve, 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 empty circle, curve, and this could be gone, the point at 3, 1, and that wouldn't matter at all, right? It's just what happens if you trace the curve. You get a limit. So the limit of f of x as x approaches 3 is 2. And that's really it. And the main thing that you need to be aware of is that like isolated points like this one, 3, 1, that does not affect whether or not you have a limit. It doesn't matter if there's a hole there. All right, so let's move on. One-sided limits. So you may have noticed, let's go back here. You may have noticed that you have to trace the curve from both sides, right? We said from the left and we said from the right. And so those actually have names. So when you trace the curve from the left, that's called a left-hand limit. When you trace the curve on the right, that's called a right-side limit or right-handed limit. And so it's possible to have a function like the function that I drew right here, where the left hand and the right hand half, they don't meet up in the middle, right? So in this picture right here, that's what happens. So like on the graph shown, we would say that the limit of f of x as x approaches 3 from the left is 2. That's because if we're going towards x equals 3, which is, right here in the middle, if you start to the left on the curve, if you trace the curve from the left, trace on the left, you end up right here. And what's the y value right here? The y value is 2, right? So that limit is 2. So the limit on the left is 2. So the limit of f of x as x approaches 3 from the left is 2, because you end up at 3, 2. 2 is the y value. Now on the right, if you're on the right side of x equals 3, then you're in this piece of the curve. So if you start here and you trace towards x equals 3, so you follow the curve, so trace, you end up down here at 3, 1. So 3, 1, the y value is 1. So we would say on the graph, the limit of f of x as x approaches 3 from the right is 1. So on the left side, you end up here at 2, the y value of 2. On the right side, you end up down here at 1, so a y value of 1, the limit is 1. And those are what we call one-sided limits. Now, what's the point? Well, first of all, there's some notation for it. Maybe. First of all, there's some notation for a one-handed limit or one-sided limit. And what we do is you write it exactly the same way as before. You write LIM for limit, X arrow A. And then what you do is up here on the A, it looks like an exponent, like a superscript minus sign. And so a superscript minus sign means on the left side. And a superscript plus sign means you're on the right side. So this right here, if you look at it, you would read this as the limit as x approaches a from the left of f of x is equal to L. And this one with the plus, limit as x approaches a from the right-hand side of f of x is equal to L. So we have a right-hand limit and we have a left-hand limit. Okay. Now, why do we use the minus and the plus? Well, it's basically this. Let me just make this a little bit smaller. Let's just number line. So if you just look at a number line, if you just think about it, right? Like if you were at 8, the left-hand side, actually, that's not what I want. Where's one with negative numbers? Do we not have negative numbers? You're killing me, internet. Yeah, here we go. This one, perfect. This is what I want. So on a number line, right? on the left-hand side, you have negative numbers, and on the right-hand side, you have positive numbers, right? So if you have 0 in the middle, negative is on the left and positive is on the right. And that's why in the terms of the notation here, we use a minus for the left and a plus for the right. Negative side, positive side of a number line, left and right. Okay, so that's why we do that. That's the notation for a one-sided limit. And then we want to know how is the regular limit going to be related to one-sided limits. Okay, so this is going to be something you need to know because it's going to be related to whether or not a limit exists in the first place. Okay, so what we started with today was two-sided limits. Okay, and that's why we had to look from the left and from the right. So if the limit from the left as x approaches a is equal to L, right? That was the first thing we did, was we approached a from the left, got a number L. Then we approached a from the right, and we got to a y value that we also called L. And then in that case, where both of these were the same number, we said that the two-sided limit, which we were just calling the limit, of f of x as x approaches a is equal to L. Okay, so what I'm saying here is basically, in order for there to be a two-sided limit, then the one-sided limits have to be the same, right? If the two-sided limit exists, then both one-sided limits exist. That's true. And if a one-sided limit does not exist, or the one-sided limits aren't equal to each other, then the two-sided limit does not exist. So if we back this up and we look at the previous example here, if we look at this previous example here, the left-hand limit was 2 as x approaches 3. Left-hand limit is 2. The right-hand limit is 1. So the left-hand limit exists and is 2. The right-hand limit exists and is 1. What's the two-sided limit as x approaches 3? There isn't one, right? There isn't one, because the limit from the left is 2, the limit from the right is 1. Those are not the same number. And so the two-sided limit doesn't exist. And the reason it doesn't exist is because suppose it did exist. What would it be? What's the two-sided limit as x approaches 3? Is it 2 or is it 1? Right? It doesn't make sense. You can't have the limit be equal to two things. So if the left-hand limit says the limit is 2 and the right-hand limit says that the limit is 1, then you don't have an answer to the question, what is the limit? Can't be 2 because this is 1, can't be 1 because this is 2. So you don't have an answer there. And that's why we would say that if a one-sided limit does not exist, or the one-sided limits just are not equal to each other, then we would say that the two-sided limit does not exist. Okay, and so in the homework sets for this week, what you're going to see is problems like this, where they give you graphs like this graph with a piecewise defined function, which we'll talk about more in the next lecture. Graphs like this with holes, or graphs like this with no holes. And what you're going to have to do is you're going to have to just look at the graph and figure out whether or not a limit that they ask you for exists. And if so, what is the value? And you're just tracing the curve. That's all you're doing. Yeah, so I think that's it. So we made it through our first lecture on limits. Our next lecture is also going to be on limits, but we're going to be looking at doing something with numbers and tables next time. So thanks for being here, and I will talk to you guys later.